Welcome to the DIY Honda Garage channel. In this presentation, we will delve into the diagnostic trouble codes, DTCs, indicating that the fuel systems for both the rear bank, P0171, and the front bank, P0174 of the Honda Pilot are operating too lean. The term lean means that there is an insufficient fuel-to-air ratio, leading to potential engine performance issues. It is crucial to understand that both DTCs may occur concurrently and indicate issues with the vehicle's fuel injection system or airflow components. The fuel system is essential for delivering the correct amount of fuel to the engine, while the air ratio plays a vital role in ensuring optimal combustion. Our troubleshooting guide will help you systematically identify and resolve these issues to restore vehicle performance. The DTCs P0171 and P0174 relate to the fuel systems on the rear bank, Bank 1, and front bank, Bank 2 of your Honda Pilot, respectively. Each bank corresponds to a specific set of cylinders in the engine, where proper fuel delivery is essential for optimal performance. These codes indicate that the fuel system is running too lean, meaning there isn't enough fuel being mixed with air for combustion. This imbalance can lead to several engine performance issues, such as reduced power or unexpected stalls. It's important to locate the air-fuel ratio sensors, fuel injectors, and other related components, as they play a crucial role in balancing the fuel supply. These sensors are generally located in the exhaust system and intake manifold, allowing them to accurately assess the air-fuel mixture. Several potential causes may trigger the diagnostic trouble codes P0171 and P0174. Firstly, air leaks in the intake system can significantly impact the air-fuel mixture, leading to a lean condition. Components such as cracked hoses, poorly sealed gaskets, or damaged air ducts should all be inspected thoroughly. Secondly, faults in the mass airflow (MAF) or air-fuel (FF) sensors can provide incorrect readings of air entering the engine, compromising the fuel delivery. If the sensors are not functioning properly, they can lead to the engine receiving less fuel than necessary. Lastly, fuel delivery issues, such as inadequate fuel pressure or malfunctioning fuel injectors, can hinder the engine's ability to maintain the proper air-fuel ratio, further exacerbating the lean condition. Identifying symptoms associated with DTCs P0171 and P0174 is essential to understand the severity of the issue. One common symptom is a rough engine idle, where the engine may shake or vibrate more than normal. This can lead to an unpleasant driving experience, highlighting potential fuel delivery problems. Another noticeable symptom is poor acceleration. The vehicle may struggle to gain speed or respond sluggishly to throttle inputs. Additionally, the check engine light on the dashboard will illuminate as a warning that the onboard computer has detected these DTCs. If left unaddressed, these symptoms can progress and lead to more severe engine complications. You'll want to address these symptoms promptly to avoid potential damage and maintain optimal engine performance. In the first troubleshooting step, we begin by starting the engine and allowing it to idle without any additional load, such as while in park, P, or neutral. This initial setup ensures that the engine operates under standard conditions, which is crucial for accurate diagnostic readings. Using the Honda Diagnostic System, HDS, we will check the short-term fuel trim, ST fuel trim, values for both banks. If the values for ST fuel trim B1 and B2 exceed the threshold of 1.33, it indicates that the fuel mixture is excessively lean. In this case, we proceed to the next troubleshooting step. However, if the values are within the acceptable range, the system may be normal. although further investigation is warranted. This step ensures we identified potential fuel-related problems early in the diagnostic process. In the second troubleshooting step, we will review the onboard snapshot data recorded by the HDS. This snapshot captures critical parameters, while the short-term fuel trim for both banks was at its highest, providing valuable insight into the engine health. Parameters such as engine speed, vehicle speed, relative throttle position, TP, and accelerator pedal position, APP sensor, are essential for determining if the vehicle conditions align with the lean condition. We will drive the vehicle under the same conditions likened to those in the snapshot and check the ST fuel trim for both banks again. If the ST fuel trim continues to exceed 1.33 while operating under these snapshot conditions, we proceed to further diagnostics. If not, the system appears operationally normal at this time, though we should remain vigilant to other potential issues. For the third troubleshooting step, turn off the vehicle to ensure safety before proceeding with the inspection. The mass airflow (MAF) sensor and intake air temperature (IAT) sensor are crucial for measuring the incoming air. Begin by carefully removing these sensors and inspecting them for debris, such as lint or bugs, which can significantly hinder their function. Any foreign objects obstructing the sensor can lead to incorrect air readings, consequently affecting the fuel mixture. If debris is discovered, it is important to carefully remove it and then use a vacuum cleaner to clean the air cleaner housing. If no debris is found, reinstall the sensors securely to continue the diagnostic process. This step is vital to ensure that the MAF sensor can measure airflow accurately and help maintain optimal air-fuel ratios. The fourth troubleshooting step involves a visual inspection of several key components that are critical for the air-fuel mixture balance. Carefully examine the crankcase breather hose, air cleaner housing, intake air duct, oil cap, and dipstick for any signs of disconnection, cracks, or damage. These components can become compromised over time or as a result of wear and tear. If any components are found to be defective or disconnected, appropriate repairs or replacements must be made. Issues with any of these items can contribute to unintended air leaks in the intake system, which would exacerbate the lean fuel condition indicated by DTCs P0171 and P0174. Ensuring all components are intact is crucial in restoring the appropriate air-fuel mixture for optimal engine performance. In the fifth troubleshooting step, we will start the engine and allow it to idle, ensuring that it is running under normal conditions. Next, pinch the vacuum hose connected to the brake booster, which is an integral part of the braking system that uses engine vacuum to assist braking. By pinching this hose, we create an artificial vacuum pressure change in the system, which can help identify any leaks. Use the Honda Diagnostic System HDS to check the ST fuel trim B1 and B2 values once again. If these values still exceed 1.33, it suggests that the brake booster itself or associated hoses are not leaking, and we can proceed to the next step. However, if the values drop significantly, it may indicate a leak in the brake booster or its hoses, requiring further investigation or replacement to resolve the lean condition in the fuel system. Continuing in our troubleshooting process, for the sixth step, let the engine idle, while we will then pinch the vacuum hose, leading to the positive crankcase ventilation (PCV) system. The PCV system is crucial as it recycles gases that escape from the engine's combustion chamber, ensuring proper emissions control. We need to observe the ST fuel trim parameters once again under this condition. If they remain above the threshold of 1.33, it signifies that the PCV system is operating correctly without any leaks. Conversely, if the trims drop, this indicates a leak in the PCV system or its associated hoses, suggesting that repairs may be necessary. Understanding the functionality of the PCV system plays a significant role in ensuring the overall efficiency of the engine and helps maintain the correct air-fuel balance. As part of the 7th troubleshooting step, we will first disconnect the intake air duct from the air cleaner housing. This procedure may require an intake manifold adapter cone from the OTC LeakMaster Evaporative Emission System Tester Kit. If you don't have this adapter, an alternative method involves removing the brake booster vacuum hose and injecting smoke into it. The purpose of this step is to utilize smoke to check for leaks in key components, including the intake manifold gaskets, throttle body, air intake ducting, and all associated vacuum and air hoses. Inspect each area meticulously for any visible signs of leaks. The presence of leaks can significantly affect the air-fuel ratio and lead to the lean conditions denoted by DTCs P0171 and P0174. If you discover any leaks, they should be repaired immediately to restore proper function of the fuel system. In our 8th troubleshooting step, we will continue to let the engine idle while monitoring the MAF sensor readings using the Honda Diagnostic System, HDS. It's crucial to ensure certain conditions are met, such as ECT sensor 1 being above 158 degrees Fahrenheit, 70 Celsius, the transmission being in park or neutral, and all engine and electrical loads turned off to provide a stable environment for accurate readings, while maintaining the engine speed at a steady 2,500 RPM for 30 seconds. You need to check whether the MAF sensor readings fall within the acceptable range of 9.2 to 13.0 grams per second, G per second. If the readings are within this threshold, it indicates that the MAF sensor is functioning correctly, and we can proceed to the next step. However, if the readings fall outside this range, it signals an issue with the MAF sensor, warranting further inspection or potential replacement. In the 9th step of our troubleshooting guide, we will need to check the fuel pressure while observing the ST fuel trim values. This entails verifying that the low-pressure fuel supply is adequate under conditions where ST fuel trim B1 and B2 exceed 1.33. The acceptable range of fuel pressure should be between 410 to 460 kilopascal CPA, which converts to 4.18 to 4.69 kilograms per centimeter squared, or approximately 59.5 to 66.7 psi. If fuel pressure is within this range, we proceed to the next diagnostic step. Should the pressure fall below this specified range, it could indicate issues such as a malfunctioning fuel pump or fuel filter, or electrical problems affecting the power supply to the fuel system components. Correcting these issues is vital to providing adequate fuel flow and pressure to the engine, ensuring optimal performance. The 10th troubleshooting step involves first turning off the vehicle completely and then initiating the on mode without starting the engine. At this point, you will clear the DTC using the Honda Diagnostic System, allowing you to reset the onboard computer's recorded faults. Once cleared, start the engine and hold the engine speed at 3,000 RPM until the radiator fan activates, subsequently letting it idle. Then, select the DI fuel pressure test. From the inspection menu on your HDS, you will need to check if the high-pressure fuel readings are indicated as normal by the system. If this reading is normal, it suggests that the high-pressure fuel system is functioning correctly, and you can move on to the next step. A failure in this test may prompt troubleshooting efforts for associated codes like P0087 and P0088, which could indicate high-pressure fuel issues. In Step 11, we will focus on fuel quality, particularly if the lean condition arose soon after refueling. Start by safely turning off the vehicle and draining the fuel from the tank to eliminate potentially contaminated or substandard fuel. After removing the inadequate fuel, refill the tank with known good fuel from a reputable source. Next, operate the vehicle under the same conditions that previously resulted in ST fuel trim B1 and B2 exceeding 1.33. While observing these parameters during driving, check whether they still remain elevated with the new fuel. If they exceed the threshold, the fuel was likely not the source of the high trim values, leading you to proceed to the next step. If the trim values align more appropriately with expected ranges, the fuel quality easily could have contributed to the error code. In the 12th troubleshooting step, we will focus on the air-fuel AF sensor, which is vital for accurate fuel mixture regulation. Begin by turning off the vehicle and replacing the AF sensor, sensor 1, with a known good unit to ensure the component is functioning correctly. Once the new sensor is installed, start the engine and conduct a driving test under the same conditions previously monitored for their effect on ST fuel trim values. After sufficient operation, observe the ST fuel trim B1 and B2 parameters once again. If these values remain elevated, it suggests the AF sensor is not the cause of the previous high readings. In that case, you should reconnect the original AF sensor and proceed to the next step for further troubleshooting. Should the values normalize, you have identified and resolved the sensor issue, thus solving the low air-fuel mixture problem. For our final troubleshooting step, we will turn our attention to the fuel injectors, which are crucial for delivering the proper amount of fuel into the engine. Start by turning off the vehicle again and replacing all injectors with known good ones to ensure accurate fuel delivery. After performing the replacement, start the engine and once again, operate the vehicle under the same conditions where high ST fuel trim values were previously noted. Watch closely for ST fuel trim B1 and B2 parameters while driving. If these readings remain high, it suggests that the fuel injectors were not the root cause of the lean condition, and the next logical step would be to substitute in a known good powertrain control module PCM to explore further. Conversely, if the injectors were the cause, replacing them should lead to an improvement in the ST fuel trim values, correcting the fuel delivery issue. The final repair verification step is critical to ensuring that all identified issues have been addressed and the vehicle is functioning normally afterward. Begin by reviewing the completed repairs to make sure everything has been properly resolved, whether it be from visual inspections, component replacements, or adjustments made. Once satisfied that all repairs have been completed, conduct a test drive of the vehicle under varied conditions, simulating the circumstances that initially triggered the diagnostic trouble codes. Monitor ST fuel trim B1 and B2 once more using the Honda diagnostic system, and check for the recurrence of DTCs P0171 and P0174. If the codes do not reappear and the trim value stabilizes within acceptable limits, you can confirm that the repairs were successful and the car is in good operational condition. Implementing a preventive maintenance plan is essential in avoiding potential issues related to DTCs P0171 and P0174 in the future. Regular inspections of crucial components such as the MAF and AF sensors will help ensure they are functioning correctly and cleanly, maintaining accurate air-fuel ratio calculations. It's also important to periodically check for any air leaks in the intake system, as these can compromise vehicle performance significantly. Keeping an eye on fuel quality by using reputable providers can also prevent fuel-related issues from arising. Additionally, Maintaining an awareness of the overall health of the fuel system, including fuel lines, filters, and injectors, can stave off unexpected lean conditions. A proactive approach can lead to smoother engine operation and better longevity of vehicle components. In conclusion, DTCs P0171 and P0174 serve as essential indicators of fuel mixture issues within the Honda Pilot. Understanding the impact of these trouble codes allows for a targeted approach in diagnosing and resolving potential problems in the intake and fuel delivery systems. The systematic troubleshooting steps outlined will assist technicians in efficiently identifying and rectifying the underlying causes of elevated short-term fuel trim values, while ensuring all components are functioning optimally. It is important to be thorough in each step, as overlooking minor issues can lead to recurrent problems and deteriorated engine performance. Preventive maintenance strategies should also be adopted to further minimize possible future occurrences of these codes, keeping vehicles performing at their best. Please like and subscribe to the channel. See you next time.